Okay, so thank you all for joining today. I'm Christopher. Just a note, if you can have a writing instrument, or a piece of paper with you, you don't actually have to use it. Like I'm not checking anything, but thought it might be helpful. As we go through, there were a couple of different questions I had, that thought it might be useful to go through. Okay, so. This is a talk about chickens and avian flu, or other things too. This is where I was working in Bangladesh while I was living there for the last year. I just finished a PhD at UC Berkeley School of Public Health, and I'm a postdoc now. I'm an environmental health scientist, which means that most of the work I do is in exposures. Most of the exposures I work on are infectious disease exposures in the environment. So trying to understand, like I worked on typhoid for a long time. So if we want to talk about typhoid, it's like if you're trying to understand how many people have typhoid, the numbers that we use are the number of people that have gone to a hospital with typhoid and then paid like 10 US dollars for a test, which a lot of people don't have, and then the test is only 30% sensitive. And so with the numbers that we have of people who have been like diagnosed with the disease are often vast undercounts of the disease itself. And we're also interested, just as we were just talking about, like with like toxin exposures, similar with infectious diseases, we want to understand how are people being exposed to diseases? What is that transmission pathway, is what we call it, in order to then reduce exposure, come up with solutions that can try to reduce exposure amongst populations. So, for introductions, I would love to learn who you all are. So, if you first want to use your piece of paper, and we'll take like 3 or 4 minutes, I have two questions for you. So, first is where do you consider home? And then, how would you describe home from the perspective of like the ma give yeah, just describe home in a different perspective. So if you were like the mayor of your hometown, how would you describe the place? Or if you were like the garbage collector, how would you describe the place? Or if you were however you want to be, just describe it in a couple different ways. And then secondly, what do you see in this photo? We're gonna at 4:25, we're gonna have two people share.
Hi, my name is Joel. My pronouns are he, him. Place that I would consider home is like fairly basic when you think of like in terms of what it is. What I think home is where like most of my family is and like places where I'm like comfortably able to like leave my belongings outside without like any fears. I don't know how a different perspective, I guess, to look at it because like the place that I considered home is really like the building which I live in. So I guess like a perspective of like a bug, it would be like extremely unsafe because like half my family is like deathly afraid of bugs. And in this photo, I see like very interesting like glasswork. I'm not sure if it's like filled with like some type of oil or not, but it's like a very pretty glass on top of like a table, which I'm not sure if it's like uneven, but like balanced on rocks.
All right, one more person.
My name is Han. I use she, her pronouns. I'm from Seoul, so I kind of consider the entire city as my home because I really like going out and doing stuff. And I think maybe the mayor would probably describe it as like rich with opportunities, like culture, just a lot, like a city that's going to become like a powerhouse. Also technologically innovative. And I also noticed the two yellow bottles. They also look like they have oil in them to me. But generally, I just see kind of like a neighborhood that people live in.
Yeah, I guess like the reason I ask these questions or use this as an introduction, and all of this is I'm trying things too, is with public health and with public health generally, I see public health or any different discipline as maybe a different lens in which we can tell a story or tell a story about a complex place or a complex set of dynamics. And depending on what you choose to study, I'm not sure how old any of you are right now or what stage in your education you all are in. But like based on what you choose to study or how you choose to study, there's different skills that we build in order to ask different sorts of questions. This photo is I associate with Seoul. I was there a few years ago as like a with an exchange program between the U.S. and Korean some different Korean environmental activists, and we were talking about Seoul in relationship to south of Seoul. There's the area with the different coal-fired power plants, and how Korea was trying to figure out like for their reaching their like net zero goals of 2050 or not choosing to have to not phase out coal by 2050, what was the impact on farmers and other people living around the those coal-fired power plants? And what were the different ways that people were trying to push for more solar power or wind power? They're very similar strategies to how we in the United States, or at least in California, we're trying to push for California state policy to shift towards more renewable energy and less reliance on oil and gas. And in California, it's also like people in like the Central Valley farming areas that are exposed to the most particulate matter, mostly from like transportation in the state. Because here we don't have a high-speed rail system, and so people are transiting back and forth Northern California to Southern California all the time, as well as like our transportation, our truck system is not electrified yet. And so how do we make those sorts of changes? What I see in this photo is I was here. This is from Benin. I was on a project where we were looking at helminth. There are these different worms, and so I was interested in this is the sewer here next to the road. It's like open sewage system, and we were supposed to be sampling from that. And I was trying to figure out how are we actually going to sample when it's all covered like this. But yeah, the glass bottles. There's so many different stories to tell in a single like image or photo. The glass bottles are gas. This is like a gas station. And the gas is most likely siphoned from the pipes in Nigeria that is like going to the coast. And there's sometimes like explosions at those at the siphoning points, including like a few days after I took this photo. This is the next country over on the gas station, and so I see it as like being a foreigner in a place. I see like whoa, like this is so different than home, but also I like what you said, Han, of like yeah, it's just a neighborhood. This is just like the normal gas station for people on their motorbikes going through Kome, and so. I think especially when talking about like global health or international work that goes beyond borders, there's a lot that can be learned from other situations, and also like there can be a tendency of othering of like oh this is so different, and so there can be a tendency to at least sometimes of trying to point out differences and say they're wrong or different in some sort of way, but it also is like what we define as normal is so based on our own upbringing. And so I appreciate getting to and like have the privilege of having worked in places very far from my own upbringing. But there are exposures in my hometown that are also a challenge. And I've also learned from other people in different places how they're trying to reduce these exposures. So, yeah, kind of going what I said. Everything is about like perspective and from where you sit, and from where we each sit changes in time as well. So this stand is where I was working for like a year in Bangladesh. And if you look the other way, if you were sitting in that banana stand, this is your view the other direction. So a live poultry market. And so putting on your public health cap, if you were me in this situation, you're an environmental health scientist. You're supposed to be thinking about what are environmental exposures. What are some potential exposures? What public health challenges do you see?
For one, I don't see running water,
And why is that a challenge?
because if you want to, just for sanitary issues, even if you maybe don't have soap, I think at least water is a very important component to have.
And why is it important to have water? What are sanitary issues?
Contamination, also, if you're working with poultry, then there's blood everywhere, and you probably don't want to leave that on the ground. Because it probably smells bad, and B, it has a lot of germs.
So germs. Why are we worried about germs here? And what germs?
I guess it could just be like general germs from the animals, and also germs that come from like exposure after like they've been killed, and if they're just sitting out there in the sun, like in open air, um, there's got to be like cross contamination, stuff like that.
Does anybody else have any other things, other challenges you notice? I can continue. I only have 45 minutes. I have unlimited slides to go through with you guys. So, um, so I guess like all I'm trying to say, thank you for volunteering. One, there is a complex system that any research question can come out of. The idea of what is a challenge or what is an issue, there are different ways of assessing or saying like this is an issue, and you can define a whole map of relationships that creates an issue. Like when I see this guy, and like what public health challenges there are, you could look at it through the lens of like orthopedics and like is this a position that is good for the body to be in all day? You can look at it through, yes, as you said, there's no water or soap in his shop. So when he goes to have lunch, does he wash his hands before he eats? You can also look at it through these chickens. We know that between 6 and 10% of chickens that show up in these live poultry markets have some form of avian influenza. And H5N1 has been in a type of avian influenza that like has spread around the world in the last 15, 20 years. But more recently, at least in California, the price of eggs has gone up by like 5, 6 times because they culled a lot of the chickens because they had avian influenza. And this space where people are coming into close contact with live poultry all day is a space where there can be potential we call zoonoses of the influenza jumping from the chickens to people. That's how they believe. A similar situation to this is how they believe that like HIV transmitted from monkeys to people in a market like this where someone was butchering and a monkey had HIV, the person cuts their finger and then they can get a bloodborne illness. We don't think that avian influenza is bloodborne. The zoonoses we don't think is bloodborne. It's important to understand what is the transmission pathway of different diseases. We think it's more like in humans the main, and I'm out of I'm behind my own slides. But in humans, the most of our receptors or the cells in which influenzas infect first are in our respiratory tract. So we think it's either airborne transmission or close contact if someone like touches avian fecal matter that has like influenza in it and then like touches their eyes or gets it in their respiratory tract somehow. We don't think that it's through like the meat itself, but there's other germs, other diseases that are a challenge in meat samples, like antimicrobial resistant bacteria. And then antimicrobial resistant bacteria is a challenge because it's not just on a meat item or like AMR, antimicrobial resistant E. coli, often is in different chicken samples, especially when the birds have been given antibiotics. But there's something called horizontal gene transfer. So it can antibiotic resistant gene can jump different species of bacteria, and we don't totally understand that entire process or when it jumps. But if someone has like antibiotics and a course of antibiotics and doesn't take it all, or has a suppressed immune system, antimicrobial resistant bacteria can be a really big challenge. There were like more than 1 million deaths due to AMR last year. And so there's a number of different challenges that occur in these settings. We were really focused on because there you can think about all the different challenges that exist, and it can be overly complex. We know that there are a lot of different directions or challenges that exist, but what are we going to solve in a very limited time? Or how are we going to pull apart this whole maze of different potential factors and choose what is our exposure and what is our outcome? How are we going to assess just that very limited part? And so this is like a prior project that I had done around like typhoid, just trying to map out all the different pathways of how is typhoid circulating in this system. So I just wanted to highlight that it's really important to define a good research question. So elements of good questions are that they're feasible, interesting, novel, ethical, relevant, manageable, and appropriate. And in some cases, we were trying to generate like systematic knowledge. So like what is generalizable outside of our specific context? What can others learn from? Also understanding that each context is unique. Each chicken market is different, but but we were trying to understand like, okay, across different chicken markets, what do we think are these pathways of exposure? So as I was saying, influenzas are a challenge, and we're worried about highly pathogenic clades jumping from chickens to people. So like highly pathogenic clades being like H5 and H7, which is the H's and the N's are the surface proteins of the influenza virus. We're worried especially about H5N1 because when that jumps from birds to people, there's been about a 50% mortality rate. As it's jumping to people more, the mortality rate is going down. But in the last 20 years, there have been like 2,000 cases of H5N1, and about like 50% of people have died. And so they're worried about like future pandemics and how do the future viruses with pandemic potential get into people. So maybe we'll just take 1 minute to think. So, given what we now know about airborne avian influenza and the market situations that you've seen, what is one research question you might ask in this situation?
I will gonna start. It is not related, all this epidemic, but when I see Bangladesh and all this what's happening, I was very curious to know, even though you did all this research, how you were gonna improve because this is Bangladesh. I know that public health, that government intervention has to be there. And how you say you were there for 1 year and then do this role, and then what is that purpose? That is, I just out of curious, and the research,
Yeah.
and with all of this research and everything, that how we're going to improve, how we're going to relate with that after this. That's I was really curious.
Yeah, I guess like this is a challenge with places that we would consider like weak states of according to the Dhaka North City Corporation policy, all chicken slaughtering happens outside of a live poultry market, and there's a veterinarian in every market that watches every slaughter. However, there are no veterinarians in any of the markets, and all the the slaughtering occurs in the market. And so I think that it comes down to this question of like what is a feasible solution? And
Right.
policy is not always a relevant or feasible solution. So how do
Mm.
we find like win-wins that benefit both the market workers or and also like make it so they can earn a bit more money, or like how do we incentivize
Mhm.
solutions that aren't necessarily through government policy or like a more punitive approach. And all that being said, like I've done a lot of my like I've worked now like 10 years with people in Bangladesh. And I like there are really good like doctors and scientists and people that are like there is so much that can be learned from folks there. And it's the situation of Bangladesh is like a post-colonial state trying to find footing in this like very in a complex world in which policies or yeah, like how does a government function when you're in debt to the World Bank by so
Right.
much, or like how does a
Right.
government I think that and this is off topic, but I thought it was really interesting when the garment workers went on strike while I was there.
Mm.
And Bangladesh, 80% of their GDP is from the ready-made garment industry. And so when the workers went on strike, because the minimum wage is $80 per month in the garment factories, and the cost of living in Dhaka is going up by like 10, 11% per year. When I first started working in Bangladesh, it was a dollar was worth 84 taka, which is their currency. Now a dollar is worth 140 taka. And so people are people's paychecks aren't going as far as they used to, and they want to like afford basic needs for their families. However, the government is worried that if they pay people more, if they say this is the new minimum wage, the companies will just leave and go to another country. They'll go to whatever country they can find the cheapest labor. And so it's a race to the bottom in some ways. And so what the government did is when the workers were striking, they told the police to use live ammunition and to shoot people who were striking. And that can't go on for long. But what the government also did is that they started like a food stamp program almost for workers to say, we understand that you can't have this isn't a living wage that you're making, and you can't feed your families with what's being paid by these companies. So here's like a food supplement that the government is paying. And so what it actually means is like the Bangladeshi government is subsidizing the profits of these companies that are underpaying their workers and putting them in like in situations that are not feasible for them to have a living wage. We have the same issue in the United States with like the minimum wage being stuck since 2008 of workers can work a full-time job and still not make enough money to pay rent. I think that yeah, like the questions of like what is a feasible intervention are questions that exist not just in Bangladesh but in the United States as well, and everywhere too. As to government policy is not always the right approach to making an intervention. Sorry, that's a tangent, but
Yeah, sorry, that is not a research question, but it's burning question to you.
but it can be a research question in some ways. Is like how do we implement how do we implement something that can reduce exposure is a research question. Or like how do we
Okay.
like implement a certain and we can go into what we asked. So the first research question that we were wanting to ask is what is the relationship between airborne avian influenza prevalence and ventilation in live poultry markets of Dhaka and Ghazipur? So saying in old tuberculosis hospitals, we know that if there's better ventilation, there can be a reduction in airborne disease spread. If there's more air exchange, then people aren't breathing as much of the contaminated air. The second thing we want to know is what are the differential exposures during the workday in live poultry markets? So is there a specific task in which people are becoming more exposed to, and we couldn't use airborne avian influenza as our outcome measure for that. So we used particulate matter, which is like a common airborne like just it's what we measure for lots of different types of pollution because it can give you we have the monitors that can say this is what your particulate matter exposure is at a given 1 minute increment when our airborne avian influenza monitor it can just say positive or not positive, and so it can't say if you're slaughtering a chicken or if you're defeathering a chicken or if you're cleaning the shop what is the biggest exposure, because we want to understand are there certain tasks that we could potentially intervene upon. And then the third thing that we want to test is what is the effectiveness of an improved air filter of improved air filtration on the prevalence of airborne avian influenza viruses in these markets. So trying to take to your point is like, okay, we don't think that a government policy is the right approach, but what if we look to what was done during COVID-19 or during the wildfire smoke times in California? People were saying, oh, this is a low-cost air filter. Would putting one of those low-cost air filters in these markets reduce prevalence of airborne avian influenza? Those were the three research questions we tried to ask during this study. I think that the other part of science that I didn't really realize when I was in like high school, really, I thought of science as like, oh, there are so many. How do we understand the theories of the world that are all around us? And there was always this sign in the back of the classroom. I don't know if you guys have a similar sign in Seoul, but it was like the scientific method is like, what is your purpose? What is your hypothesis? What is your experiment? How do you do your analysis? What is your conclusion? But this space between hypothesis and experiment, I just wanted to say like it's a lot more complex and there's a lot more steps to those pieces. And I spent all my time going between this little bit of between hypothesis and experiment. So like what is the research question specifically? What is your funding for the research? What is your ethical approval that you need? What is our standard operating procedure? How do we train a team as to what we're supposed to do to collect this data? How do we optimize these protocols? How do we pilot our data? How do we set up our systems for collecting data? How do I train my team? How do I clean the data and make sure it's all clean in order to analyze it? And so the methods of what we did to assess these research questions, we went to 4 different shops and 10 live poultry markets, and we selected these shops based on their prior enrollment in another study. There was another study that had already looked at the environmental factors in these different markets, and there were different biosecurity practices in place in different markets. And so we wanted to utilize that data that was already collected and add something onto it. And we wanted to collect information on the particulate matter, which is like airborne particulate matter, the ventilation rate, so how much air is circulating through this space. We wanted to capture bioaerosol capture of the influenza M gene, so that's can we capture the virus from the air itself? And then we did a survey trying to understand what are the different practices the workers have in place, like what you were saying, Hoyan, of like do they wash their hands? Do they use soap? Do they use water when they wash their hands? And we have to worry about bias with that because some people might say, "Oh, you're from a hospital. Of course you want us to say that we wash our hands." And so we would look for a hand washing station as well, and look and just like watch what was going on. So for particulate matter sampling, this is one of our monitors going up. We use these PATS Plus particulate matter monitors, and we keep it on a shopkeeper table, and we collect data for 1 hour. This is just to say how much overall airborne contamination is there with the PM 2.5, which WHO says is harmful if it's above 5. And we wanted to say, because these monitors, you can collect this data for free once you have the monitor. So we wanted to say, if they're in places where there's more particulate matter, does that also mean there's more airborne avian influenza, the outcome that we're interested in? And that would be called using a proxy. So how good is particulate matter as a proxy for airborne avian influenza? The second thing we wanted to do is ventilation monitor measurements. So what the World Health Organization says is that if there is more than 12 air changes in a room per hour, it's probably safe for reducing airborne spread of viruses enough that there's not going to be a secondary transmission. This varies by disease, but 12 air changes per hour is considered like the golden line. And so we wanted to see how much air change is there in these different spaces. So what you do, and this is my colleague Shohan, we puff a carbon dioxide air extinguisher in the middle of the space, and then that carbon dioxide decays over time, and we can measure the slope of that decay curve. It's basically just like it's doing in like the math that you probably know, it's like it's doing a derivative. It's just taking that slope, and that slope is the air changes per hour of how much carbon dioxide change is there over time. Yeah, so this is what our data looks like, where the x-axis is time and the y-axis is carbon dioxide. And we put different carbon dioxide monitors around the shop. And so we pump the gas at these different black lines, and then we measure this decay line to see how much of ventilation changed, like what is the ventilation rate of the space. The third thing we did is collect the bioaerosol monitoring results. So this is our bioaerosol monitor. And so it takes air at 3.5 liters per minute, and it separates it into 3 different filters. We collect that data for 1 hour per shop, and then we analyze it using PCR. Does anybody in this group know what PCR is? So PCR is I didn't know this one until college, and now it's like now I just like use the letters, and it's a polymerase chain reaction. So it's basically how you detect if there is DNA. So have you ever gone to the hospital to get like a blood test? So or like the COVID test up the nose? You guys have gotten that before? So
Yep.
what they do when you do that is that they will take your blood or your saliva and they will extract it depends on if it's a virus or a bacteria. Because viruses, some of them, their structure is DNA and some of their structure is RNA. So for influenza, the the viral structure is RNA. our cells are DNA. That's probably too detailed. So what you do is you can just extract the base genetic code through a process called like extraction. And then based on what that genetic those genetic fragments, you put them in it's kind of like doing a recipe. It's like putting it into a pot. You have your genetic fragments of whatever your sample was, and then you have some stuff called like a master mix. And then you have forward and reverse primers. So that is if you have a DNA or RNA sample, we usually have for DNA, it's double stranded, right? People know what DNA looks like, right?
Yeah.
There's two strands. So you have, if you've done the extraction step, it's one strand, and then you add these primers that are supposed to only connect to the specific elements of a DNA that make it unique, that make influenza, or like human, or HIV, or any of these different things. You can order these primers online for like $3 or $4. They're really cheap. So you can order those primers, and then if your sample has whatever you're looking for, whatever attaches to those specific primers, you can say that sample has that bacteria or has that virus or has that whatever. And the process of doing that is called PCR. It's really cool, I think. It's like it's almost automated now. It's like you can there's robots that do it. So what we were doing is that we had influenza primers. We take our sample for an hour. We do the extraction and we put it in the PCR machine with the influenza primers and see if there was influenza. And then we also want to say like we want to make sure that there's a if a sample says it's positive, we actually believe it's positive. There's not contamination in our other samples. So we also want to take a negative control because we only have a couple pumps. And so we want to make sure that if after we clean the pump, it actually has cleaned all the influenza from one shop out. So we'll do a negative control after cleaning the pumps. And then we also do a positive control. So that's saying we know that there is influenza in this specific hospital sample of influenza from a patient. Let's put it in and do the same process that we've been doing in the field and try to ensure that we know that our assessment is working. Does that make sense? I look at like the head slightly nodding to see if something makes sense.
Yeah.
So thank you for your slight nods.
Yeah, we have a very few minutes left, so that's one of
Sorry. I haven't even gone through the methods yet. Sorry. This is why I could talk for unlimited amounts of time. So then the last thing we do is like a cross-sectional survey. So what that is you can set up like an online survey for people to fill out. It needs to be HIPAA compliant, which means that it doesn't share people's information online. So that's why we use this system called REDCap. There's other forms of collecting data online. So you can use like a Google form. You can use ODK Collect or Kobo Toolbox. These are online like data collection platforms. So this is what an ODK form looks like. Here's an example one. If you ever want to use an example, it's free to use. And then we did worker exposure testing. So we attached these monitors to different workers through their workday, and then we took every minute of the day, we wrote down what they were doing and then compared what they were doing with what the exposures were that we were measuring. So we took different workers from different shops and then we built like this ventilation system and we put it in a shop just because we wanted to see if it would work. And then we talked to the workers and say, did they like it? So there's some general characteristics about the markets. There's like 20 or so shops per market. We sampled 4 of them. Less than 20% of the markets were the government went to inspect with these biosafety inspections. The chicken cages are cleaned. Only in about 30% of the markets are they cleaned every day. And then markets on average, or like shops on average, had like more than 2 fans in them. There's ventilation rate versus like the difference in particulate matter that I was trying to say like yeah, how is the particulate matter related to the ventilation rate? And what we see is there's not a clear correlation of even when there's high ventilation, we don't see less particulate matter in the shop compared to outside. But we do see that on average, this is the PM difference is the amount of particulate matter inside to outside. There's a range depending on the market, but generally there's more particulate matter inside these markets than there is outside. And so we were hoping that that would mean that particulate matter is, so this is exactly the same thing actually. The ventilation rate on the y-axis, and then particulate matter estimate on the x-axis. So we don't really see a relationship that's clear of more particulate matter is, we would expect there to be when there's higher ventilation, there to be less particulate matter. But what we do find is that there are high levels of avian influenza, airborne avian influenza in these spaces. So 100% of the shops were positive. These are just the different size fractions because we were able to measure avian influenza in these 3 different size fractions. So on average, there's 8,000 copies of avian influenza per cubic meter of air. What does that actually mean for risk to human health? That's another question. And what we also see is that the ventilation, this max air changes per hour, is not really related to the amount or the number of copies of avian influenza that we would expect. So what I was saying about there being like a golden number of how many air changes you'd want in a space, we're not really seeing that with our data. For the worker assessments, what we see is that also across different so what we're looking for is in each of these different tasks, are there any tasks that are significantly different than the others in terms of people's exposure to particulate matter? And the only task that we see is smoking. Is when people are smoking, there's more particulate matter. But the other tasks in their workday, we're not seeing a big difference in particulate matter exposure. And then yeah, in terms of the thing that we built, it's also not associated with decreased concentrations of airborne avian influenza. There are a number of limitations in this study. So like the seasonality, the different methods of aerosol data collection, varied building structure. Our monitor placement is different just because the shops are different. And there's a question of the sample positivity not necessarily being related to a known risk in human health. Just because we measure something in the air, does that mean that someone is going to be sick? When talking to a bird market worker, we'll say like, are you worried about like we've collected airborne avian influenza from your shop? And he's like, well, I'm not sick. So does that mean that the collection of this sample or the amount of RNA that we find in the air is what does that mean for human health risk? And I have some discussion questions. And then I had a whole second half of this presentation because I wasn't sure if Betsy wanted me to go for 2 hours. But I think that the other thing that, so this is also a picture from Bangladesh. The other thing to note is that like, we exist within systems. And this is when the government was collapsing in 2024 and like the military was going in to shut down protests. This is like on the way home to where I lived. And so just like in all of this, we can measure an exposure, but we're existing within a whole larger society in which the need for change or like making changes are related to larger projects or programs that need to get funded. And this project was a part of a USAID project that was meant to redesign bird market spaces and to really like think through and work with engineers to try to build and test out what a hygienic live poultry market would look like. And that funding was cut by the Trump administration, and so the project just kind of stopped. And so these are still risky spaces. We've better characterized their risk, but the funding to actually try to reduce that risk is non-existent, and our team pretty much all got laid off with the USAID cuts. So
Wow. Wow.
um,
Wow. Yeah.
yeah,
So can I ask a quick question?
yeah.
What is, I know you're a postdoc right now. What do you want to do if, perfect word, do you have a lot of fun, a lot of funding that you can do? That what do you want to achieve?
Well, I think that like this entire thing is like we're talking. I would like for people to be less exposed to harmful infectious disease exposures. People are in choose jobs where they're highly exposed because they don't often have that many other choices. A lot of these people are migrants to Dhaka from
Mhm.
other parts of the country, where climate change has made it so it's infeasible to farm anymore, or like sea level, like saltwater intrusion to farming areas. Um, and so like if there were, I would love for there to be funding to try to reduce like exposures in these market spaces and work alongside poultry market workers to try to say like what are the challenges that you're facing. And most of the challenges when I ask them those kinds of questions are like economic challenges. And
Mhm.
so what is the relationship between economics and disease exposure risk? I think is really interesting.
Yeah.
I've been working with like folks in the Rohingya refugee camps in southern Bangladesh. And for that, it's like again, it's USAID cuts have like closed all the schools in the camps.
Mhm.
If I had more money like to do like work, or what I already spend some of my money doing is like how do I support like youth-led organizations there that's trying to like fill those gaps, or like how do we work collectively to say like these are human, like these are basic human rights that need to be upheld, like the right to education, like the right to a safe workplace. And I think that the question globally is like what are our accountability mechanisms for making sure that people can have a safe workplace where they're not going to be exposed to harmful infectious diseases. And we don't have that in the United States. We don't have that anywhere really. Like OSHA exists in the United States and tries to reduce exposures. But there are just harmful exposures that we're put into contact with on a day-to-day basis. And that's similar to the work that you're doing with toxin exposures of yes, there can be exposures that workers face, but then what is the policy change, or what are the next steps, and trying to learn how to work alongside workers and trying to figure out what those next steps are.
Thank you. Thank you. Is there any questions? Is the second slide for Bangladesh refugee that's
Yeah,
related with that? Yeah, I'm very interested in. But today we have to stop, but I will talk to Dr. Nas if we have a time slot to do that, that I really interested in. If you
yeah, and also if you guys want to talk to some folks in the camps, like I can, depends on the time, because this would be really early their morning time, but I can bring in Ro or Ajas to like talk with me, or they can send a video, because yeah, I have more slides on some of that work that we're just publishing now. Um,
Mm,
but yeah, there's questions as to like what does ongoing support for that look like? And I think like the goal that I don't think I hit in this talk, because I went down the rabbit hole of chickens and trying to talk about DNA things. But I think like the overall thing is that everything can be like every part of our lived experience is public health. Like living
right,
a healthy life, living in a place where like we're not exposed to extreme heat. Like these are all public health challenges. And there's so many like different ways of approaching public health, whether that's working in a company, working in like you don't have to be working on a vaccine to be working on public health. Like improving people's lives anywhere in
right.
anything that you do is part of a public health solution. Like the lady in Chinatown that gave me like her like homemade chili sauce today and like totally made my day. Like that's in some ways like she's a public health practitioner in doing that. And so yeah, like there's lots of different ways of being part of a public health solution.
Okay, thank you so much. I will
Um,
definitely talk to Dr. Nas, and then I will gonna can you send, give me your what is the email address in the chat?
yeah, yeah.
I will follow up on that, and then I'd love to have a slide, and then we can, some kids they're not coming, and then they would like to see what a recording. That will be awesome.
Yeah. I can send you the slide links or just send it to you via email.
Right, let's do that. Okay, thank you. Thank you so much.
Sounds good. I'll see you all.
Okay.
Thank
All
you.
right,
Have a good day.
bye.